So today we are simplifying polynomials. When you walk in the morning and you see everything on the board and my PowerPoint, like we had listed before, hold on, I'm going to want that you're putting that information right up here, okay? We're going to do something called Cornell notes, where in the left-hand column, okay, in the left-hand column, you are writing down any kinds of questions, ideas, or words defining power words. And in the right-hand corner, we're going to be taking our notes, okay? So for right now, all I really want you to do is write monomial, the definition. In fact, don't write another line at the bottom of that. I want you to leave it open in case you need more room. You don't write the bottom line until you're done with that section. So is everybody clear on what to do at this point? Yeah. Okay, so here we go with monomial. Who can tell me what a monomial is? Go, Kaylin.
It's a group of numbers or numbers and variables tied together by multiplication or division.
Numbers and or variables tied together by multiplication and division.
And separated by subtraction or addition.
Right, and it's a single term. It's a single term, okay? So it's a single term consisting of numbers and or variables. All right. Now, I also want you to notice whole number exponents. Whole number exponents. What does that mean? What are whole number exponents? Yes?
An integer above 0.
Okay. A number greater than 0, 0 or greater. Our whole numbers start at 0. So if I had 4x to the 5th, is that a whole number exponent?
Yes.
Yeah. Absolutely. 5 is a whole number. But what if I had 4x to the negative 3rd? No. So that wouldn't be part of the monomial family. It's a term, it's just not a monomial. Because to be a monomial, it has to have a whole number exponent. And if I had 4x to the negative 3rd power, how do I write that in fraction form? Logan?
4 over x to the power of 3.
So anything with the variable and the exponent in the denominator means, is this a monomial? Yes or no? Yes.
No,
Why?
because it's not a whole number.
Right, because when it's in the denominator, if I were to write it not in fraction form, we know it's a negative exponent. So if you see a variable with an exponent in the denominator, any kind of variable, even to the first power, in the denominator, it is not part of the monomial family.
If they can be combined with multiplication or division,
It's just your end result.
isn't division always to the power of -1?
No, because we could have, well, let's take a look at some, okay. Did everybody write in your Cornell notes, did you write your definition?
Yeah.
Okay, so now I want you to write a line in it. You've got, monomial, definition, and you're going to draw a line, and now you're going to do monomial example. Or you can just write example. Okay? Here was our definition, which is all of this. Is that making sense? Now we're going to do an example. You with me, Gideon?
Yeah.
Okay, who else? Jason, you with me?
Yeah, I'm just reading one.
Okay. All right. So one example would be 7x squared. Can anybody else give me an example of a monomial? Go, Jonah.
10y to the 3rd.
10y to the 3rd. Okay, go.
1x to the 3rd.
Okay. Does it have to have a variable? No. Could it be 10?
Yeah.
Absolutely. Okay. Could it be Could it be without an exponent, just to the first power? Yes, 3m. We could do 10ab squared c. These are all examples of monomials. They're tied together by a multiplication or division. Questions? Okay, pause the recording, finish writing. The question is, because there's a negative and a decimal here, isn't this not a monomial? Well, this says whole number exponents, and this is to the first power, this is to the second power. These are all whole number exponents. That's all they're talking about, not the coefficients. The coefficients are allowed to be negative. The coefficients are allowed to be decimals or rational numbers. Yes, RJ.
When we're at home and taking notes, do we have to do the same thing? Like everything we're writing
Okay.
now?
All right. So, now let's go on to the next. Draw a line under that, and you're going to say polynomial. Polynomial. Polynomial goes on the left. The definition goes on the right. What is the polynomial? Anybody have any idea? Good guess. Adam.
A multiple.
Okay, so he said multiple terms. Poly means many. So yes, that means many terms. Okay? You don't need to write all the words that I have. You can abbreviate this. 2 or more terms. 2 or more terms, probably what I would write. 2 or more terms, probably all I need to write. Many. I would write the word many. Now, I draw a line under that. And you are going to write, give me an example. Poly example. And so a polynomial is 2 or more terms. So I could do 4k minus 6. I could do 4k squared minus k minus 5. I could do 5x squared plus 2y plus 3x plus 5z. Many terms. Okay, questions? Question was, for a monomial, can it be just a number? It could be 3. Let's add that to our list of examples. Okay, it could be just x. It could be a number and or variable, or both tied together. Now, within the polynomial family, oh, did you need that? Okay. Pause the recording and take your... Okay, within the polynomial family, you have multiple polynomials. Different kinds of polynomials. The first kind we're going to talk about is called a binomial. Binomial. I'd probably put this over here and just give it its own box, right? Right? Binomial. What do you think that stands for? Go.
2.
2 terms. I'm going to put the example right there. If you want to draw a line and then do another box for examples, that's fine. But this is such a small definition. One example would be 4x minus 3. 5x squared plus 2. 2 terms. Another type of polynomial, I guess I should probably under here and write binomials and trinomials. Okay, another type is called trinomial. What do you think is a trinomial? Jean? 3 terms, like our tricycle. Can somebody give me an example of one? Go, Jonah.
2x plus 3y minus 7x.
Good. No. Those two terms are alike. So when you would combine them, then you'd end up with 2x minus 7x. That's 3y minus 5x. That's a binomial. That's not a trie. So your terms have to be three different kinds of terms. So, do you want to clarify?
Sure. 2x plus 3y minus 7z.
Good. Okay. We could do 2x squared plus 3x plus 1. These are examples of trinomials. Pause the recording and finish up the notes. Okay, your question first. Did you already forget it?
The only thing I asked is, like, is there, like, a quadnomial or something like that?
No. Anything more than a trinomial, we just call it a polynomial. So 4 or more terms, we just call it a polynomial. Okay?
Yeah, you answered my question.
Okay. So, can I erase this? Yeah. Okay. So now, what we're going to do is now, when you're given a problem set, okay, when you're given a problem set, you should have enough room that you could kind of abbreviate the directions. And abbreviate the directions, and you're going to say, identify. I'm sure you're probably supposed to do that straight, but I can't really fix it. Huh? Under that last line. And now you're going to start writing your problem set, okay? So for instance, let me pull up my, I really should make a better, okay? Whoops. Okay, let's go here. All right. No. Okay, I'm going to put this over here. So, right here is where you can just put your problem set. So, notice the directions. It says identify each expression as a monomial, binomial, trinomial, or polynomial. More than one may apply. So you are going to identify. So I'm going to put number 1 here, and I'm writing 4x minus 6. You write the actual problem. Now tell me, is this a monomial, binomial, trinomial, polynomial? Let's go with Mason. It's a binomial. Is there anything else that applies?
Yes.
What else, Gideon?
Polynomial.
And polynomial. You can abbreviate. Number 2. Now, I'm writing in a very small space. You should be able to do at least two columns, right? Yeah, you're writing this down. Okay. Number 2. Notice it's 18x squared. Can you read it to me? Minus
6x squared plus 7.
Oh, was it squared cubed?
Yeah, squared.
Plus 6x squared minus 6x squared. Go on.
Plus 7x.
Plus 7x. Okay, who can tell me? Amani?
Is that negative 6x squared?
Yep.
Okay, so it's monomial?
Monomial is one term.
Yeah.
How many terms are in this?
It was 3.
3.
But I was
Okay, so what is it? Clarify.
thinking trinomial.
It's a trinomial. What else? Or is the trinomial? Is there anything else? No, it's to the third, to the, to the first. This is to the third, the second, and the first. No, they can't be simplified. What else could it be called, Riley? A polynomial. Okay? Do you understand? So you're going to do your problem set right there. 3. 9t to the 4th. Okay, pause the recording and finish that up. Oh wait, I have to get rid of that piece. Okay, let me get rid of that. Okay, pause the recording. All right, so let's look at number 1. We've already done it. It's a binomial. I'm just catching up. And a polynomial. Number 2, we called that a trinomial and also a polynomial. Number 3, can anybody tell me about number 3? Sam? A monomial. Is it part of any other group? No. Number 4, Gideon. Polynomial, and that's it. Okay. Number 5, let's go with Louis. Polynomial and binomial. Number 6, let's go with Dion. Polynomial and trinomial. Okay, so the next set of, draw a line, and our next problem set, the next problem set, okay, as you, the next problem set that you're going to do, what are the directions? What are the directions? Yep.
To say if it's a polynomial.
Is it a polynomial? Abbreviate those directions. Keep going. What else are the directions?
If it is, say what's the coefficient?
How about in order? What else? What's the second direction?
How many terms are there?
Number of terms. Abbreviate that. Number of terms. I don't mean the hashtag. And then the last part is coefficient. Okay? That's an abbreviation for coefficient. It's just all I'm doing is abbreviating the directions here.
I just couldn't read.
Okay? And I'm having to write really small. So, on number 1, I'm going to write it x squared minus 3x plus 8. All right, so here's my first problem. The first thing it asks, let's see, maybe is white. Can you see the white? Yeah, okay. So, the first thing it says is identify if it's a polynomial. Is it?
Yeah.
Okay, it's a polynomial. And then it says, state the number of terms. How many terms does this have, Riley?
3 terms.
3 terms. What is the and then the last part says, and the coefficients. What's the coefficient of the first term? Go.
1.
It's 1, comma, right? Keep going.
-3.
And -3. And we're just looking at the variable terms. Now, this is debatable. Some people say that 8 is a coefficient for x to the 0. Okay? Because x to the 0 equals 1. Some books claim it that way, other books don't. We're going to call 8 a constant term and not look for its coefficient. Okay? Okay, and then you go on to number 2. You ready? Do you understand what to do? Okay, go. You're doing the problem set, writing our notes, pause the recording, and finish up the problem set. Let's go. Let's continue. Number 3. How about Andrew? It's not a polynomial. Number 3 is not a polynomial. Number 4. Okay. Number 4. Louis.
It's a polynomial.
It's a polynomial.
There's
How many?
4.
4 terms.
Yeah.
And what are the coefficients?
7, -1, and -4.
7, -1, and -4. Okay, next one. Who thinks they have this? Louis.
Is it not a polynomial?
It's not a polynomial because if I were to write this not in fraction form, it would be 4t to the negative 2 power. And remember, to be a monomial, it has to be a whole number exponent. So we would say not a polynomial. What about number 6?
Yes.
RJ?
Oh, yes.
It is a polynomial. How many terms?
2.
2 terms. Okay, 2 terms. Hold on, maybe I should stand up. 2 terms. And what is the coefficient, RJ? 1/3. Notice we have a 1 and a 3 here, so that becomes my coefficient, 1/3. Yeah.
Why is 5 not a polynomial?
Why is 5 not a polynomial?
Because there's a fraction.
Go re-explain it. Re-explain it. Shh.
So basically,
Shh.
it's not really like a x or something like that at the end, but some people think it's like x to the
No, that's not what I said. Why is this not a polynomial? Sam. Because the variable is in the denominator, it means it's 4t to the negative 2 power. What is the definition of a monomial? Whole number exponents. Is this a whole number exponent? No. So if it's in here, it means it's a negative powered exponent. So if it's in the denominator, it is not a polynomial. It's not a monomial. Questions? All right, let's move on. Okay, next one. Next box, you're going to write. Give me a minute. You're going to write standard form. And you're going to write the definition. Okay? Hold on. Wait, I said to you. Now, your next one you're going to write. Okay? How about this? How do we write polynomials? Or we could write standard form. You could write standard form. And then we can write the definition. So the question is, how do we write our polynomials down when you're communicating to me? Okay? Now, standard form means the powers of the variable are written in decreasing order. Okay? Powers of the variable are written in decreasing order. Pause it, write that down. Now, okay, we're going to explain this. So, here is a non-standard form example. So, what I want to show you is how to, right? This is an example of standard form. Your writing should be straight across. You should have enough room, but I'm on a little iPad, so I'm going to explain. You need to hold on. Okay? Now, let me explain the definition. What does that mean, powers? What are we talking about, powers? Go.
It would be like cubed, squared to the 4th power.
Squared, all the exponents, okay? The exponents are written. We put the polynomial with the biggest exponent to the smallest exponent. So which term has the biggest exponent? Which term, Emerson?
Plus 7x5.
Positive 7x to the 5th. So I'm going to write that first. Okay? What is the next biggest exponent, Ford?
The next biggest exponent is x to the 4th.
What kind of x to the 4th?
Negative.
Good. So I'm now writing negative x to the 4th. Okay? The next biggest one, Oliver?
4x to the 2nd.
4x to the 2nd, and it's positive. And then the next biggest exponent, Riley,
Negative 3x.
to the first, right? We don't write the first, but negative 3x. I'm going to remind you it's to the first. And then what else? What goes last?
8.
Yes. Plus 8, minus 8, plus 8. Now, theoretically, why is that at the end? Because it's x to the 0 power. Anything to the 0 power equals 1. 1 times 8 is 8. So this is what we call standard form, where the exponents, we put it in order of the exponents from the biggest ones to the smallest ones, in decreasing order. Yes?
What if there's two of the same exponent?
We're going to combine our like term, and I'll show you that next. Okay, Gideon, do you have a question now?
It was just whether this should be its own box or it wasn't about the actual.
It could be standard form example, or you could just keep, it doesn't have to be, whatever. Okay, is everybody clear what it looks like in standard form?
Yeah.
So the question here is, how do we write our polynomials? We write them in standard form. If you're giving me an answer on a quiz, that's how I'm going to want to see it. That is like the norm in math, the way that you would give it to your math teacher. Okay? In standard form. All right, so now let's practice. Draw another line, and let's put them in standard form. Yeah, you could say practice. You can call it practice. Practice standard form. How's that? Your next line, we're here, we're making our, you can now call it practice. Yeah. Pause the recording and try the next few on your own. All right, so let's look at number 1. How would I write it? So I'm putting it in standard form. Maxime.
5y to the 4th
Uh-huh.
plus y minus 2.
Perfect. Okay, next one. Okay, next one. Let's go, Greta.
2m to the 5th minus m to the 3rd plus
Minus m to the 3rd. Loud.
plus m plus 6.
Good. Number 3. Let's go with Emerson.
Negative t to the 6th plus 4t to the 3rd plus 8t to the 2nd plus t
Good.
2.
Minus 2. Excellent. Next one, let's go with Ethan.
Negative 2k to the 4th
Good.
plus k cubed plus 9k squared minus 3.
Perfect. Okay, so it is expected when you give me an answer that you put it in standard form. Yeah.
In the example, you did plus 8x to the 0 power.
Oh, I don't expect you to write x to the 0 power.
But if I did that, is that okay?
No, don't write it. We don't want to see it. Okay, now, simplifying. This is going back to Ford's question. I don't understand. Why can't we put them all together? Okay, I'm going to remind you. An x, I want you to think of it like it's a tile. An x is like this. Okay? And an x squared looks like this. And an x cubed looks like this. Wait. Sorry, it's supposed to be a cube. I'm usually better than that. It seems like there's a line missing. Let's do this. Okay, so, shh. Okay, so, if I have like, let's say we have 3x cubed. I have 3 of these. And let's say I have 2 x's. I have 2 of these. Sorry, 2x squareds. These are x squareds, right? Because if this is the measure of an x times x, doesn't that make x squared?
Yeah.
And this one is like an x
times an x, 3 dimensions, times an x. Okay, we call that x cubed. So an x cubed is never going to be an x. An x squared is never going to be an x cubed. Okay? Think of it like an x. Let's just say an x stands for a small drink, an x squared stands for a medium drink, and an x cubed stands for a large drink. The price of a medium will never be the price of a large. We can't take 2 mediums and it's going to equal a large. Does that make sense?
Yeah.
So they all go in their own pile. This is like sorting things back in kinder. Only now we're sorting terms. So we start with our biggest exponent. What's the biggest exponent, Ford?
7x to the 4th.
Good. And are there any other x to the fourths?
3x to the 4th.
So I have 7x to the fourth, and I'm positive 7x to the fourth, and I have another positive 3x to the fourth. How many x to the fourths do we have?
2.
We do not have 2. We have 3, and then we have 7. Altogether, that makes 10. So all we really do when we put them in a pile is add the coefficients. X to the fourth is a like term. We're adding the coefficients, okay? Now, usually, once I add them, I usually circle them or underline them so I know I've used them, right? What's the next biggest exponent? Ethan?
Negative x squared and 3x squared.
Negative x squared. Good. And 3x squared. And how many x squareds does that make?
1.
1.
Just x
So it's
squared.
positive x squared. But you need, is it positive or negative every time? Okay. Is there anything, what would go next? How about Emerson?
5x plus 5x.
Okay. I've got plus 5x
Plus 9.
plus 5x. There's nothing to go with it. And my last term is plus 9. Okay? We've combined our like terms. Can I make it any simpler? No. Basically with this, I don't even know what the fourth dimension would look like in drawing. But the second, I've got 2x squareds, I have 5x's, and I have 9 single digits. Does that make sense?
Yeah.
Okay, so now let's try it.
No, wait, don't get rid of that.
Okay. Can I go like this?
Yes.
Can I just do it like this? Or do you want it in color?
No, I'm like,
All right. So, draw a line under that and say examples. Examples or practice, yes. Practice. So now you guys are going to combine your like terms for number 1 and 2. Pause the recording. Okay, let's get started. What am I going to combine? What are we combining? How about somebody I haven't heard from? Someone I haven't heard from. I think I've heard from a lot of you. Gideon,
Okay.
what am I starting with?
So the first thing I did was I combined and then I did 6.
Whoa, what does that make? Shh.
Oh, and that makes negative 5 to the 5th.
Negative 5t to the 5th. Next one. What am I doing?
Then I combined 6t to the 2nd and 5t to the 2nd to make 11t to the 2nd.
Positive or negative?
Positive.
Okay, I'm recording and I'm going to appreciate if you stop. Continue if you can answer this correctly and without playing. Go.
And then I did negative 7t and t.
Okay, I'm doing negative 7t and positive t. What does that make?
Negative 6t.
Okay.
And then
I'm gonna go here. Let me make it a different color.
6.
And then we have plus 6. Okay, I'm going to do plus 6. Good. We're not leaving anything out. So I either circle or draw the lines so I don't leave anything out. Okay, next one. Tell me what you guys did. Go, RJ.
an 8 thirds with negative 8 thirds.
Good, and that makes
Negative 5a to the cube.
negative 5a cubed, okay?
Then I combined negative 9a and added 3a.
And that makes?
Negative 6a, and then minus
Whoa, whoa, whoa,
a,
what are we skipping?
the negative a.
No, we went from negative 5a to the third.
Oh no, then I made them, like I did that.
Okay, I want to go in order because I don't like to do two steps. So what would be the next biggest one?
6a squared.
Keep going. And is that it?
Yeah.
Okay, so we're not combining it. And then the next one would be?
Negative 9a plus 3a.
And that makes?
Negative 6a.
Negative 6a.
Minus a is negative 7a.
Negative 7a. Notice there were 3 that we combined that time. Are we done?
Yeah.
Yep. There we go. Okay, questions. I'm going to stop the recording there, and that is the lesson.